Hi guys, welcome back to week 2. So this week we're going to be talking a little bit about solar energy. But before we do that, we need to understand how a circuit works. So in order to do that, I'm going to show you a diagram and we're going to talk about how electrical current or electricity travels so we can understand what we're going to be doing with our solar project when we go outside. So right here I have two pictures. In this picture you can see I have a battery and a light bulb. Now this would be an LED, one of those little bitty light bulbs. And from this I have a wire going from my battery to one side of the light bulb. Let me get something to point with here. I have a wire going from my battery around to this side of my light bulb, and from this side of my light bulb I have another wire going back to my battery. Now my battery is my energy source, and that stores what kind of energy? Potential energy. And that energy can go out and be kinetic energy moving through the light bulb coil back to the battery, and that's what makes our light light up, which is our kinetic energy. That's when the energy is moving, correct? Okay, so this is what we call a closed circuit. That means that it is a nice round circle and that the energy can travel around and around and around that circle, and it can light up a light, it can run a fan, it could run your iPad or your Chromebook, it could run a refrigerator. And now, would a refrigerator be running off a battery? No, it would be coming from electricity. But it's the same thing. Whether it's a battery or electricity right here, it still needs to have this closed circle in order for the energy to do its job. Now, that's called a closed circuit. Now, an open circuit means we have an energy source, in our case a battery, but it could be electricity coming from the wall, and we have a wire that goes out to our light, and we have a wire coming back. But if you notice, it's not connected right here. Now this would be considered an open circuit. And in an open circuit, you don't get any electricity traveling in the circle. So this light, see if I can mark it off. That light can't light up because the electricity can't travel in that circuit. So when we're wiring our solar greenhouse or our solar house here in a little while, and if something's not working like our fan or our light, the first thing we're going to make sure is that all our wires are connected so that we don't have an open circuit. We want to make sure we have a closed circuit. All right. Now there are some cool websites you can go to on YouTube. You can put in open versus closed circuit or open closed circuit. And there are really some good websites that can explain this even more if you don't understand it here. And I'll talk about it a little bit more when I get outside with the solar house. All right, so we're going to take a quick break, and I'm going to move from my studio to the outside. Hopefully we can hear okay because it's a little windy out there today. Okay guys, before we go outside to the hot sun, I was going to do this real quick in my kitchen and show you a demonstration of an open and closed circuit using a battery. I have two AA batteries here in the pack, and each battery is 1.5 volts. If they are 1.5 volts and I'm using 2, how many volts of electricity or potential energy have I got stored right here? So I'd like you to figure that out. Okay? You can share that back to your teacher in your Google Classroom. Now, we talked about an open and closed circuit. So this battery pack has two wires coming off of it. There is a red wire and a black wire. And I'm going to show you the difference between an open and a closed circuit. Now, we said a closed circuit meant that the electricity or the power could travel all the way through and around into something. we're going to make it travel into this Christmas light. So I had an old set of Christmas lights and I just cut them apart, and I've got this nice little light here. Now, one thing with a light, electricity or energy will only travel one way through this. So it has to go in a positive side, travel through the light bulb, and come out a negative side. Same with this. Our red is our positive wire, and our negative is our black wire. So I need to figure out which one of these two wires on my light is my positive and my negative. So if it doesn't light up the first time, I know I've got them backwards. So right now, if I put one wire here to one wire of my green, and to do this so you can see it is a little difficult, I'm just going to hold it. And then I take so right now I have an open circuit because these wires are not touching. If I touch them together, I then have a closed circuit. And I did get it right. I have my positive power going in one side and my negative power going out the other. Now you can see it blinking a little bit. That means that I'm not holding these two wires together well enough. I have to make sure that they're touching really well in order to have a closed circuit and allow the energy to travel through the light bulb, which lights it up. Now, I could do it this way. I could have my negative on the other side and not have these two wires touching, and now I have an open circuit. But let's close our circuit, and when we close our circuit, we can see we get light. Okay, that's a light bulb. I also have this nifty little fan. Now, this is a fan blade, and I've attached to a small motor. This is a 1.5 volt motor. That means it doesn't need a whole lot of electricity or energy to run. And down here are the two little places where my energy comes in, one on one side and one on the other. Now, with a motor, this particular type motor, the direction of the energy doesn't matter as much. So if I have my positive one side and my negative the other, it means the blade's going to turn one way. If I reverse the energy, then the blade will actually turn a different way. So what I'm going to do is I'm going to complete this circuit. And I'm going to take my black wire, and this has a little hole in here, and I'm just going to stick it down in that hole. Now I have to make sure these wires don't touch each other, or they don't touch anything metal, because then it faults out. So I have it in that one. Now I'm going to take my red wire. So right now I have what kind of circuit? My wire's not touching. I have an open. And if I touch it to this side, oops, my fingers are in the way. Stick that back in there. Well, let's give that a little bend so it'll sit in there better, like that. All right, get my fingers out of the way. Okay, so I'm an open circuit. What kind of circuit was that? That's right, I now have a closed circuit. When the fan runs, my circuit is closed. That means the energy is coming from my battery pack and going to my fan through my wires. Let me see if I can hold this up a different way where you can see it a little better. So I have my black wire over here. So this is hard to hang on to, it's so little. And I have my open circuit because this wire is not touching. So let's touch this wire, and there it goes. I can make my fan turn. So now I have a closed circuit. That means the potential energy that was stored in the batteries is now transferring through the wires, through the fan motor, and making the fan move and transferring back to the batteries. I have a closed circuit, and my energy can travel all the way around the circle. All right, so now we've explored with electricity. I'm going to be moving outside in a minute. So what you see here, I've designed this cool little house. And you can see there's wires sticking out all over. And I actually have a battery pack on either side. And I did that originally because inside my house, I have a light, which is another Christmas tree light, just like this one that we used. And I have my fan. And you can see I used a popsicle stick so that I can mount my motor to my ceiling, kind of like a ceiling fan in any room you might have in your house. And then I made this little paper blade just because I thought it was cool. And the wires for the motor are coming out the top, and the wires for the light are coming out the top. Okay? So we're going to take this outside and we're going to work with this. One of the things we're going to work with while we're out there are photovoltaic cells. And let me get those and I'll be right back. Okay, I'm back. Now this is a photovoltaic cell or a cellular cell. This is going to take the energy from the sun and absorb it on this black surface. And you can kind of see there's some little lines in here. And that's going to take that solar energy and transfer it, store it in here as potential energy, and then through the wires, and you can see there's a red and a black again, just like on our battery pack. It's going to let that energy leave the photocell and transfer to either my fan or my light. Now these are about 1 volt per panel. That's how much potential energy they have, is 1 volt per panel. Now if you'll recall, our battery pack, how much did you figure out our battery pack had? We said that was 1.5 and 1.5. So that would be 3 volts. So now we have to decide how many of these solar cells is it going to take to light the light, or to make the fan spin, or to make both of them work at the same time. So we're going to move outside. I'm sorry if it's a little noisy. My neighbors decided to start mowing the yard. And we're going to see what happens with these. Okay, I've moved outside to the yard, and you can see I've got my little house here, and I've got my LED, or my little Christmas light up here, and I've got my little fan. And I brought out my stack of solar cells. So we're going to turn this around, and we're going to talk about this real quick. So you can see my solar cells have a red wire and a black wire, and we make sure that we connect our red wires to our red wires and our black wires to our black wires. If we don't, nothing will work here. So let's try first just to see if we can get enough energy from one of these to make our little light light up. Now I will tell you it's hard to see in the sunshine. We're going to go ahead and we're going to attach these, and I like these because they got little alligator clips. It makes it much quicker. So let me make sure that I'm touching the wire. I don't want to be touching the plastic insulation because then I can't get my electricity to move through my metals, because we know that that's what they need. And it's so warm out here I can't hang on to them. Alright, now, and I have to have this so that it's getting full sun. So I'm going to set it right up here like this on the top. Okay, and now I'm curious if my light's lighting up, and I'm going to peek back here in the shade. Alright, I'm going to turn it around. So I've got to keep my photo panel pointing towards the sun. If I point it away from the sun, it can't take any of the solar energy in. So I'm going to actually hold this up, and I'm going to spin the house around. And it's a little hard to see in there, but the light is actually lighting up. Now, is it as bright as it was in the house? Not at all. We are only using 1 panel. In the house, we were using a full battery pack, and that was how many volts? 3. This is roughly 1 volt. So the light bulb is not getting as much energy out here as it does on the battery. All right, now let's check our fan. So I'm going to disconnect this. Actually, I'll just leave that laying there. Okay, so our little light's on. I'm going to take another solar panel, and I'm going to attach my red wire to the red wire of my fan. Let's get this up here and hooked. Okay, and hook my black. Catch it. There we go. Now, let's get this put up here in the sunshine so it can see it. Now I'm going to just give it a little turn. And there we go. So the fan is running on 1 solar panel as well. So how many volts is it using? It is using 1 volt. Now we said that was a 1.5 volt motor, correct? So if I were to hook more panels in, and this is my question I want you to answer to the teachers. If I were to hook in more than 2 panels to my light and to my fan, do you think that they would be brighter or spin faster? That's the question I have for you to give your opinion to your teacher in your Google Classroom. Okay?